Hey everyone, we're going to be working on the warm-up for Geometry Day 21. So it says show that the triangle QPR, so this one, QPR, is similar to triangle QTP. So if we want to determine whether these two triangles are similar, first we have to draw these two triangles separately. So here I drew QPR, that's the bigger one. Then we're going to need to do the smaller one, which I have right here. We just got to be careful. We got to make sure that all of our angles correspond and all of our sides correspond. I see that T is where my right angle is, so I should be making this vertex T. And then I see over here, if I go T and I go up to Q, that tells me that I should be making this angle right there Q as well, which leaves P to be this vertex right there. So now we have both triangles separately. If we want to show that these two are similar, then all we have to do is figure out whether they have two congruent angles or not. I know that, oops, wrong color. I know that angle P is congruent to angle T because they're right angles. So because they are 90 degrees. So that's angle number 1, which is congruent. And then I also notice that both of these triangles actually use angle Q twice. So this is angle Q and that's angle Q. So we know that angle Q is congruent to angle Q by the reflexive property because they are the same angle. So that is enough information. This is angle 2. Therefore, we know that, or we can confirm that, triangle QPR is similar to triangle QTP, just because they share these two angles. So that's part A of the warm-up. Part B of the warm-up says the following. Diagram, this diagram shows a triangular ramp leading up to the entrance of a building. How long in feet is the vertical support shown in blue? So we have to find this height right here in blue. We do not know what it is. Because we don't know what it is, we're going to give it a variable name. I'm going to give it the classic name X. And just as before, as in part A, we're going to want to draw these two triangles separately so that we can get a better idea of which parts correspond to which. So we have the bigger triangle that goes like this with a right angle here. And this is 2 feet. And then this very long leg has got to be 24 feet. Right? It's this big length right here. And then we're doing the smaller triangle. I'll put it right here on the side. Also has a right angle. We have that the height is X. That's what we're trying to find. And the base is going to be 6 feet. So before we can even start to solve this problem, once again we have to figure out whether they are similar or not. So let's see. I see one angle is shared right here and right here. So that's angle number 1, the right angle. And then angle number 2 has to be this one right here. Notice how both triangles, just like in this example, use the same angle down here by the reflexive property. So those are two angles. Once we know that those two angles are congruent, we can say that the triangles are similar. And so we can start writing our solution. So these triangles are similar but that's not what they were asking for, right? They were asking how long is this blue part or this blue part that I now put over here as an X. Well, now that we know that these are similar triangles, we can already set their the ratio of their sides in proportion so that we can find X. So the way that I'm going to set this up is I'm going to go from big triangle to little triangle, and so it'll look like this. 2 over x should be equal to 24 over 6. So remember, the order for this does matter, so just make sure you're consistent. If you're going to put the little one on top, you got to make sure you put the little one over here on top as well. But now that we're here, this is a perfect proportion. We can now cross multiply. So we'll cross multiply like that. In order to continue solving this, I'll continue this right here on the side. 24 times x is 24x. And this should be equal to 2 times a 6, which is 12. And then lastly, we're going to go ahead and we're going to divide. We're going to divide both sides by 24 to isolate my x. So this right here is big 1. 1 times x is just x. And 12 divided by 24, that's actually 1/2. If we simplify, we can divide both of these by 12. And so we'll get that x is actually 1/2 feet long.